All right, so this problem says a car with a mass of 1,000 kg, this is a small car, accelerates from 0 to 90 kilometers per hour in 10 seconds. That's pretty slow. 90 kilometers an hour is about 60 miles an hour. And I guess one of the more expensive Teslas will do it in 2 seconds, under 2 seconds. So they ask you, what is the acceleration? Okay, so first you have to convert all these guys into meters per second, kilometers per hour. A kilometer is 1,000 meters. 1 hour is 3,600 seconds. So essentially you're dividing by 3.6. Okay. 1,000 kg car is a small car. Okay. So so final velocity is okay, so final velocity is 25 meters per second. Initial velocity is 0. .5 meters per second squared. All right, what we'll do is we'll write this acceleration in terms of g's. And you'll see why I'm doing this. So all I've done is I multiplied your answer by 1. This will cancel, and 2.5 divided by 9.8 okay, you'll see in a second why I've done that. Okay, so part B says what is the net force acting on the car? So the force is mass times acceleration, and mass is 1,000 kg times acceleration is 2.5 meters per second square, 2,500 newtons. That is the force on it. But let's do the force like this. It's mass times 0.26 g. 0.26 mg. All right, the net force acting on the car is 2,500 newtons. Okay. Does this number mean anything to you guys? It's just a number. Look at this number. The force acting on it is, there's the weight. It's 26% the weight of the car. Okay, so that is sort of more meaningful. So a car engine applies a force equal to 26% the weight of the car. If the engine could apply the thrust in a vertical direction, could this car take off? No. Okay. So a rocket, a lot of standard rockets, what they do is at liftoff, the thrust is about 1.7 times the weight of the rocket, and that thing will take off. And anything above 1 it'll take off. And as the rocket, as it burns fuel, it gets lighter, and the thrust is maintained the same, and it goes faster and faster. All right. All right, we'll do one more of these. Okay, so a rocket sled accelerates at a rate of 49 meters per second square. This is, if you divide that by 9.8, see that's 5 Gs. So this sled is accelerating horizontally, and the seat is exerting a force of 5 times your weight on you, a horizontal force. Okay. Its passenger has a mass of 75 kgs. Calculate the horizontal component of the force the seat exerts on his body. Okay, so that's the force that the seat exerts on his body, and this is just m times a, and the acceleration is 49 meters per second square, which is, again, I'm just, you can calculate the numbers, but this is 5 mg. That divided by that is 5. Okay. So the horizontal force exerted on the person is 5 times the weight, and there's the force of gravity, which is mg. So the net force on this person, there's 5 mg and there's mg. Okay, so the net force is the sum of those two forces. So this says calculate the direction and magnitude of the total force the seat exerts on the body. Okay, so there's the force of gravity, and the force that the seat exerts is that. Okay, so F1. So the net force that the seat exerts is this plus that. And that would be the net force. And you guys can add those two forces together. Okay, so F1 will be 0I plus mgj. F2 will be 5 mg I plus 0j. Add the two vectors and calculate the magnitude. You guys understand that? Anybody want me to do that? All right. All right. So this problem says a fireman has mass m. He hears the fire alarm and slides down the pole with an acceleration a, which is less than g in magnitude. Write an equation giving the vertical force he must apply to the pole. Okay. Okay, so here's a fire station. There's Okay, so I guess here's a fire station. The trucks are all here, and the firemen are, living quarters are up there. A fire occurs, and then they slide down this pole. Okay. Of course, they could jump down. They'd get there faster, except that it's not good for their knees. So they slide down. Yeah. Now, of course, this is the architecture, because these stations, most of these stations, you need them in the big cities. Big cities, land is expensive. Okay, so you need a big parking garage, and so you don't want to waste all this space, and that's why you have this structure. Okay? All right, so now you got to preserve your knees. So again, if you just jump down, your acceleration would be g. So what you do is you grab onto the pole and you apply a force like that. So the net force on you, so you still want to accelerate downwards. So this is the force of gravity. This is the friction force that you're applying by grabbing onto the pole. Okay. So mg minus, okay, and you learn we denote friction forces by little f. Okay. So the friction force is equal to mg minus ma. If his mass is 90 kg and he accelerates at 5 meters per second square. So if you free fall, your acceleration would be 10 meters per second square. Now by applying this friction, now your acceleration is only 5 meters per second square. Okay. So what is the magnitude of the applied force? What is this force? Okay, and mass times g minus 5 meters per second square. And again, you can put in the numbers 90. Okay, I'll put in the numbers 90 kgs times 9.8 minus 5. Okay, so this will work out to be okay, so the friction force is 432 newtons. Okay, now that's less meaningful than this way, mass times 9.8 g. Will convert this to g. 5 divided by 9.8 times g. So so the friction force is half the person's weight. Okay. So, of course, if you apply a greater friction force, your acceleration will be slower. Your knees will be preserved longer, except that you're trying to get to the floor as fast as possible. Okay. So those are the two opposing things that you're considering. All right. This problem says a truck collides with a car, and during the collision, the net force on each vehicle is essentially the force exerted by the other. Okay. Okay, so what we are saying is the following. The force that the truck exerts, so this is the force on the car, this is the force on the truck. Newton's third law says these two forces are equal and opposite. Okay, so in this collision, what would you rather be in? The forces are equal. You want to be in the truck, obviously. Why? What's that?
There's a higher mass.
Okay, so higher mass, the forces are the same. The higher the mass, the smaller the acceleration. And remember, we talked about accelerations are bad for your health. Okay, so that's the reason why you want to be in the truck. Okay, so let's put the numbers on that. All right. So a truck collides with a car and during the collision. Suppose the mass of the car is 550 kg and the mass of the truck is 2,200 kg. And the magnitude of the truck's acceleration is 10 meters per second square. Find the magnitude of the car's acceleration. Okay, so the two forces are the same, so the mass of the truck, acceleration of the truck should equal mass of the car, acceleration of the car. Okay. Acceleration of the car is mass of the truck. So if you are in the car, since the car is 1/4 as heavy, you're experiencing an acceleration 4 times greater. Okay. All right, this is an interesting problem. Okay, if you get stuck in sand or mud, here's a good way to get your car out. Okay, you can attach a rope, and we tend to just pull straight on the car like that. Here's a better strategy. You tie the car, and you have to have a cable, let's say a metal cable, tied to another object here. You have to tie it taut and then push on in this direction. You push perpendicular to the cable. What you'll see is, if you push, there's the tension in the cable. So this, as you can see in the diagram, this pulling force is many times greater than this force. Okay, so this is a force multiplier. You could apply the same force here and you'd get nowhere. Okay? So you could apply it here, and that's what you're getting. Okay, so this strategy, you get to form a force multiplication, and we'll see what is the multiplication factor. Okay. And all right. So the driver attempts to get the car out of the mud by exerting a perpendicular force of 610 newtons. So that's 610 newtons. And the distance she pushes in the middle of the rope is 1 meter. So this is 1 meter. And this is 6 meters. While she stands 6 meters away from the car on the left and 6 meters on the right. What is the tension in the rope? So the tension in the rope is the effective force with which you're pulling the car. Okay. So now we'll reduce this diagram to so. Okay. So we'll say this is an equilibrium. Okay. So what we are saying is, this is F is 610 newtons. And that's the tension, that's the tension. So if you think of that link is at rest, and these are the 3 forces that are keeping the link at rest. Okay. The tension in the rope, this tension in the rope is pulling that link that way, the tension in the rope is pulling that link that way. Okay. All right, before we solve this, okay, let's do that. We'll solve for this angle. This is 6 meters, 1 meter. So this angle is theta. Okay. Tan theta is 1/6. Theta is all right. So now let's go back to this diagram. Okay, the x component of the tensions, this x component is balancing this x component. We don't have to worry about that. This point is at rest, this link is at rest. The y components of the tension are balancing the force. The y component of the tension in that direction is balancing the force F. So T sine 9.46 plus T sine 9.46 equal to F. That plus that is equal to F. So T equal to so it's 3.04 actually. Yeah. Okay, so by employing this strategy, what you got is you pushed like that and you got an effective force of 3 times as great pulling the car. Okay, so you can think of this as a simple machine with a mechanical advantage of 3. Okay. Of course, if the rope is tighter or more stiffer, then the mechanical advantage will be greater. Okay, so smaller this angle, greater this force will be. Okay. All right, so this problem says, what force must be applied to a 100 kg crate on a frictionless plane inclined at an angle of 30 degrees to cause an acceleration of 2 meters up the plane? So you want an acceleration of 2 meters up the plane. Okay. We just learned all this. There's the weight of the crate. It's frictionless. This guy is mg cosine theta. This guy is mg sine theta. Okay, so gravity wants to pull the crate down. If you want the crate to accelerate upward, you have to apply a force. And this force had better be greater than that, okay, to accelerate up that way. So we'll look in this direction, okay. So F minus mg sine theta equal to mass times acceleration. So the force you have to apply is equal to m Okay, we'll put in the numbers. So you can put in the numbers here. That would be 100 kgs. That would be 9.8 meters per second square. Theta is 30 degrees. And the acceleration is 2 meters per second square. All right, I'll go ahead and do that. And then we'll do it the real way. So 100 kgs times 9.8 sine 30 plus 2. So 690 Newton. That's the force you have to apply. All right, let's do it in a more meaningful way. So F is m times G sine 30 is 0.5 and 2 meters per second square. You divide that by 9.8. So 2 divided by 9.8. 0.2 Gs. So this is 0.7 mg. Okay, so the force you're applying is 0.7 mg. And that was the point of this incline. This is a simple machine. What was your goal? To lift the box from the bottom to the top, to that height. You could have lifted it straight up. To lift it straight up, you have to apply a force of mg equal to the weight. But if you're not strong enough, then what you do is you get an incline like this, and now you're applying only 70% the weight. Okay, so your mechanical advantage of this machine is the output force was mg, the input force was 0.7 mg. Okay. 1.42. So for every pound of force you're applying, you're getting an output force of 1.42 pounds. Okay, so the incline is a simple machine. Can you increase the mechanical advantage of that machine? What would you have to do to increase the mechanical advantage? Lower the angle. Yep, there you go. Okay. All right, the velocities of a 3 kg object at t equal to 6 seconds and at 8 seconds are, so there's the initial velocity and there's the final velocity. If the object is moving at constant acceleration, what is the force acting on it? Okay, so acceleration is change in velocity divided by change. Okay. And so V final is okay, so there's the acceleration. So the force is mass times acceleration. So that's the force acting on the object. Okay, so two forces are acting on a 5 kg object that moves with an acceleration of 2 meters per second square in the positive y direction. Okay, so the acceleration of the object is 0I plus 2j meters per second squared. If one of the forces acting on the object, if one of the forces acts in the positive x direction and has a magnitude of 12 newtons, what is the magnitude of the other force? So F1 is 12I plus 0j. So they tell you F1 plus F2 equal to mass times acceleration. Okay. So the force F2 is M is 5 kgs times 0I plus 2j minus 12I plus 0j. So that's 10j minus 12I newtons. F2 is minus 12I plus 10j newtons. Okay, and so you have F2 and you can calculate the magnitude. So the magnitude is so F2, the magnitude of F2 is that, and we can calculate the angle as well. Okay, so F2 is in the second quadrant. Okay. Okay, so your calculator will give you this angle. We know our vector is in the second quadrant. This is in the fourth quadrant, so this is not it. So the other solution is 39.8 plus 180 degrees. That's the solution we want. So that's 40.2 degrees. Okay. So what you have is F2 is like that. No, okay. F1 is that. F2 is this. Okay, so F1 is a force like this. F2 is a force like that. The x component of F2 cancels that, and it gives the object an acceleration in this direction. Okay. All right.